get started. So, introduction, as Preston told, I'm part of MediaMonks. I'm a technical director there, and we are quite large. I won't spend too much time on this, but we are with 1,500 plus monks over a lot of offices in a lot of countries, and we're still expanding. And this is Qdance, and I don't think this is quite big in the States, but maybe it is. I saw someone in there from Australia, and Qdance is also doing events there. This is some footage of DEF CON 1. This is their biggest annual event, which also was planned to be have on 2 weeks ago, but unfortunately also canceled due to COVID-19. But here you can see some footage from last year, and throughout the slides you will see some imagery from these kinds of events, so you have some kind of idea what these guys are doing, and it's pretty amazing. And so Qdance is part of the ID&T group, and they are doing a lot of their own events: Climax, DEF CON, Capital. As you can see, they replaced the C with a Q to make it their own identity. And they also have hosted stages on Tomorrowland and Mysteryland, which are some of the largest outdoor festivals that you can find all over the world. It's good to know that Qdance fans are very loyal. Qdance just had their 20th anniversary in February. It was also their last event they could do due to the virus. I was there. It was amazing. And as soon as these people see an event being in sale, they go to the website immediately to make sure it's not sold out. And they all want to have their tickets whenever they got live. So that's something that we needed to deal with. So one of the biggest things that the client wanted to solve here was that they sell their entrance tickets, but also there's bus travel going there, and there's merchandise, there's hotels and camping sites where people want to stay over for the weekend. So there's lots of things you can buy around the event without just getting an entrance ticket. And what they did before was just telling a user like, okay, if you want to have hotel tickets, please go to travel.qdance. If you want to buy merchandise, go to shop.qdance.com. If you want to buy the events tickets, you go here. And it was pretty messy. And also, they would have to redirect users to third parties. Like if you want to have the bus travel, go to this party. And what their goal was of their CTO coming to us, like, okay, what we want to solve is we want to have a single place a single web shop where users can click whatever they need and just pay once. And that's what we call the one-stop shop. As you can see here, the available products that you can buy currently are entrance tickets, also accommodations, so that's hotels and camping tickets, bus travel, merchandise, parking tickets, also lockers, which you have at events sometimes where you can store your jacket and your phone and such. And also you can enable insurance, so you pay a small fee, and whenever something messes up and you cannot make it, you will get a refund or a partial refund. So the main challenges for us to solve is that you need to manage stock in real time. So there's a limited amount of tickets for the event. There's a limited amount of tickets for a hotel. And also there's a limited amount of shirts that you can buy. But we needed to manage those ourselves because we cannot call in a high performance environment. We cannot use HTTP calls to constantly call all the other parties to ask, like, do you have this still available? So we quickly decided we need to manage all the stock ourselves. So we import the stock once, and then that stock needs to be reserved for our shop, which is very important. I will get back to that later, how things can go wrong there. Of course, we need to be dealing with many different vendors. Like everything of the things you just saw is its own vendor. So ticketing is a vendor, hotel entrance, it's all their own vendor. But it's important that the user only pays once, because for the user it should be a single transaction with all the products in there that they've selected. And the additional challenge that the client gave me was, okay, I don't want to have running servers. Just make it serverless. The client is very tech savvy, so that makes it a lot of fun working with them. And he was he's fond about serverless, so he said, like, I don't want to have any VMs or running EC2 instances, make it serverless. So luckily we have a lot of experience there. But I first want to explain you what serverless is. Not sure, please put in the chat if you have any experience with this. It's fun for me to know. But I want to explain you when is something called serverless. I put it in quotation marks because serverless is, of course, a very weird term because there's servers involved because it needs to run code, it needs to run somewhere, and that is on a server. What is meant with serverless is that there's no provisioning, so there's no setup scripts or configuration required on your end. I see Paul's using AWS Lambda, very cool. Firebase, nice. Serverless is also auto-scaling, so you put something on there and it should auto-scale. If it's not being used, you don't pay anything. If there's 1,000 users on the same minute, it will just scale to the need. Also, it means it's fault tolerant. So if something breaks, the hosting provider should take care of it, triggering another time or trying another time. For this project, we were running on AWS, and we're only using cloud-based managed services. I'll dive into details later. And we're using functions as a service, and I think this needs some explanation. As Paul said, AWS Lambda is the serverless solution, the functions as a service on AWS, Amazon Web Services. And basically what you do there is you write a function, and it could be JavaScript, so Node.js, or Java, or Python, doesn't matter. You can also do it in PHP. I've also ran Drupal on Lambda. It actually works, really cool. Something for another session. But you can upload your functions there and just trigger it through HTTP, or when a file is being uploaded, you can trigger those functions and do something with it. Our frontend is decoupled, so it's the frontend is created by a third party, and they interact with us through APIs. We're using a headless CMS, Contentful, and we're doing an event-driven architecture, so everything is based on events. So architecture, I think this is the most exciting bit. Let's dive in. There's a lot of components. I'm not sure if you can see my cursor. Can you see that? Probably not. I know there's a delay in chat.
Robert, what we're seeing is your components slide with the front end pointing to API. Is that what we're supposed to be looking at?
Yes.
Okay, great.
I see some are seeing the cursor. I'm moving it. Small cursor. Okay, small is fine. At least it's showing something. That would be nice in real life. I can just put my finger on the screen. But so the front end in yellow, that is a separate piece in this architecture. It's not being developed by us, but it's communicating to our APIs. And there's a stock sync, which I will show later how that works. The API is talking to several kinds of databases and a file storage, which is S3, which I think most of you probably know. Then there's an order handler component, which takes care of when someone actually paid and it needs to be transferred to all the vendors. There's an admin tool, and there's a cart cleanup, which I'll also show later. So, as I mentioned, Qdance fans are very loyal. This is an event that was done, and you see there's 32,000 people in the queue to get tickets, and that's quite big. And of course, we cannot let all these people in at the same time. We also have a ticketing vendor which told us, like, okay, we cannot do more than 10 transactions per second. That's the ticketing provider that's also acting as the payment provider. So we had to use a queue, which luckily was provided by the payment provider. And basically what happens there is someone gets into the queue, they will get a token. And if the queue takes care of sending someone to the actual front end whenever they are first in line. The token is sent along and being sent to our API when a new cart is created. We verify that token by asking the queue, like, okay, is this token actually valid? Did it pass your queue? If it doesn't, a user is sent back to the queue immediately, and they need to wait from the beginning. Also, it doesn't help to open more tabs. The queue is smart enough to cover all of that. So that's how we handle peak sale. It's a configuration. You can just enable or disable this verification, and so as soon as most of the tickets are sold, we will disable peak sale mode, and users can just enter the front end without waiting. So we're using AWS. This was a requirement from the client, but also our preferred cloud hosting provider. And these are some of the services that we are using. I hope you won't be tired at the end of the session by seeing so many different services. Please flag in the chat if things are unclear. I will try to answer it immediately, and else it might be something for the end of the session. So as I mentioned, the front end, it's built by a third party using Vue.js. They're using Contentful. This is not managed by us, but I've seen it, of course, how they're managing this. And this is, I think, maybe the only touch point with the decoupled days itself. But I'm very excited about Contentful. Also, it could have easily been done with Drupal or another CMS. Eventually, they take all the content from the CMS and generate a static page with it and put it in an S3 bucket. So it always loads fast, and there's no HTTP request that needs to be done on the fly. How does this look on AWS? Well, the browser just goes through CloudFront, which is the CDN, and it loads all the content directly from an S3 bucket. So this is all static pages. It can take any load that we like. So no worries there. The front end talks to our API. The API takes care of getting all the product details. It manages the carts and orders. And also there's some business rules in there, which the client can modify. So usually they have a sales period where, like the first week, where only you can buy a ticket to the event if you also go to a hotel or go to the camping ground. That's just to make sure that all those places are first being taken, and then they go to the next phase. But of course, they need to make sure that people are not tricking the system by buying all the tickets without having an accommodation. So we created this business rule engine where they can define using tags on every product. Like if you buy, you need to buy at least 4 entrance tickets, and you need to buy at least 4 accommodation tickets. And there they can, using tags, can create a real flexible system where they can basically have all their use cases there. So it's this was a pretty important thing that we created for phase 2, and it's working out really well. So what's interesting is that for this project we're using Serverless framework. It's the open source version of it. And using Serverless framework, you can build all of these tools and also all the managed services in AWS. You can do it all by code. It's called code as infrastructure, and you can define the databases that you have. You can define the tables that they have. And if you then type serverless deploy as a command, it will just make sure it will send it as a package to AWS. And AWS takes care of setting up all those services. And it will return you endpoints for the API. It's a really beautiful tool. As you can see, configuration is through YAML file. Powerful command line tool. We've used it primarily with AWS, but it also supports Google Cloud. Not Firebase though. Firebase has its own great command line tool. But there's many other providers that it supports. Also, it's multilingual, so you can use it with Node.js like us, or with Python, or with Java, even PHP. Really awesome. And there's also plugins to run your functions locally. So for the API, where the browser is connecting to CloudFront, CloudFront is connecting to API Gateway, where basically a URL is transformed into it has an endpoint which ties to a Lambda function, which is a piece of code. And through that piece of code, we connect to Elasticache, Redis, which is a managed Redis service from AWS, and an S3 bucket, where we store our order data. And the order handler is it sends the emails, it informs all the vendors that tickets have been sold or merchandise have been bought, and it also takes care of monitoring. But first I need to explain you a little bit on how you can tie things together. Like you've seen that Lambda function, and it can run one function. Just like you do in your regular code, it should do one thing. And sometimes you need to do multiple things in a row. And if something fails, you might want to use another path. And this example shows you the basics of a Lambda or a state machine. So here you see you start, and you might have uploaded a photo. So you see here there's a photo coming in, and it will check the image type. So here it will extract the data. There's an image type check, and it might not be supported. It might not be an actual image, or it might be a bitmap image, which we don't support. Then it will fail. If it is an actual valid image, like a JPEG or a PNG, then it will go to the next state. And then we want to do two things in parallel. We might want to figure out like what's shown on this picture, and also we want to generate a thumbnail of it. And then if both are done, then we end. So that's how you can connect all these different Lambda functions in a single state machine. And for this state machine, they call it step functions in Amazon. Also on Azure, they call it logic apps, but on AWS it's called step functions. And what we are doing, if someone actually buys tickets or buys merchandise, any of it, we generate an order file, a JSON file, and we put it on an S3 bucket. As soon as that file is placed in the bucket, it will trigger a Lambda function. And we only needed to do this because there's no direct way to do triggering a step function from the S3 bucket. There's no way to do it directly yet. So we triggered a Lambda, and the Lambda basically starts executing a step function, and it passes the order details from the file. And then this is I think the most difficult part to explain. What it does, on the left, it starts, and it has the order data present. It will send a confirmation email to the user. For that, we use simple email service from Amazon. It will send an email. Then it needs to inform all those vendors. But this has to be done in parallel, because a user might have bought many or products from different kinds of vendors, and they all need to know that the user bought those. And only after those are done, we can send the details email, but not before. Because all the vendors need to be informed before we can tell the user, like, okay, you bought your tickets and you bought your merchandise, but if there's something with your order, please go to this party, and then this is your order number. So we must know all those order numbers before we can send them those detail emails. Next slide, I will show you how this will work by informing the vendors. If the order was succeeded, if all the vendor informs succeeded, it will send that email, and it will move the order from unprocessed to processed. And if that happens, then it's done, and everyone's happy. Confirmation email was before the payment. No, it was, we have the users paying on the front end, and after that is done, only then the order file will be put on the S3 bucket. So if the user didn't successfully pay, the order file will not be put in the bucket, and this whole process will not trigger. So the informed vendor part, that was the most difficult, and it caused me quite some headaches, but more fun than headaches, because this was such an interesting puzzle. What it's doing, it's in parallel checking for every vendor, like, okay, does something need to happen for this vendor? If it doesn't, well, continue, nothing to worry about. If it does, then it will put that vendor detail or that order detail into a queue for that vendor. And that queue, based on how busy it is, a Lambda will pull that queue. That happens automatically. You can tie those together. It will pull for that queue, like, is something that I need to do in this queue. It will take an order and it will send that to the vendor. So that's all done by API calls, of course, and it will just send the details from the user and what they ordered to the vendor, and then the vendor knows what happened. We got the order ID, and we can go back, and if that's all collected, we can send that details email. Also, we do some logging into an S3 bucket, so if something is messed up, we can figure out by going into the S3 bucket, see what happened, if there's like an error, if there's a rate limiting error or a validation error. So if all of those informed vendors are successful, then we're done. Of course, we also have some background tasks that we need to work with. We have stock updates because eventually tickets and products will sell out. Carts need to be cleaned up because someone can go to the shop, start shopping, and then later think like, okay, I don't have any money, or maybe this is not the right event for me. Or they call their friends, like, do you want to buy tickets? Oh, you already bought them? Okay, then I will quit. And they just close their browser, but those products are being reserved for the user. So we somehow need to give those products back into the stock. So what we do there is we decided to give everyone a certain amount of minutes to order. And that depends on peak sale mode or not. So I think in peak sale mode, you have 10 minutes to complete your order, and then you will be thrown out. During outside of peak sale hours, you have, I think, 1 hour. So that's very generous. There's also a countdown timer in the front end, so users are, of course, made aware of this. Also, we have some dashboard statistics when a sale is happening. But the requirements were quite interesting because, as I mentioned, the cart cleanup and the stock updates, we need to somehow, depending on the mode, we might want to send stock updates to the client every 5 seconds. But if we do that all the time, then it will, of course, cost a lot of money because we do need to pay money to AWS for processing power that we use. So outside of peak sale, we might want to send updates maybe every few hours or not at all. And what I thought was tricky is that I can have some kind of a cron, but if I change the cron, it needed to, the change needed to be immediately. So if it's set to once per 8 hours and I set it to once every 5 seconds, I didn't want to wait another 8 hours to trigger that change to seconds. So that should happen immediately. Luckily, there's something called CloudWatch. It saves all your logs, and it can generate also events, and you can use that to create a cron. And that is a really nice feature. But unfortunately, it goes only down to 1 minute, just like a regular cron. So you cannot go trigger something every 5 seconds because CloudWatch will only allow you to go every minute. So what we did there is we can also trigger that Lambda and invoke a step function, which then does stuff in the background. And then I got the idea of creating a dynamic cron. And this could be quite difficult to understand. And so let me know if it's not clear. I start the cron with an interval. So this could be anything from hours to days to seconds. It will look up if there's a current. It will go into step kill. So it will look up, is there a current execution running? If so, it will stop the current execution. Then it will execute the actual piece of code that I want to do. So that could be stock updates or cart cleanup. Then it will evaluate, because I can create, for every time it runs, I keep a counter. And here it will evaluate, like, did it reach the maximum amount of steps? There's I think it can do 25,000 steps for one execution, and then it will just stop. So I need to make sure that it will never reach that amount. If it didn't reach that amount yet, I will wait for the amount of time that the interval is. So that, again, that could be seconds till to days. If it actually is close to the amount of 25,000 steps, it needs to restart. So it calls another lambda, and it creates a new instance of itself. And then this function, or this step function, it stops. It kills itself. So that's how it can keep running continuously. And if I want to, in my dashboard, change the speed, I can just send it with a new interval, and it will always kill its current instance. And that's how I can create a dynamic cron that can be as granular as once per second. And outside of peak still, it can be once per day, something like that. So stock updates, how do we do that? Because we need to push information to the client. We are using IoT Core for that, also a service from Amazon. And it can do MQTT over WebSockets. Not sure if there's any home automation users here, but MQTT is a nice protocol where you can send data over. And AWS does this over WebSockets, but you need to first get a URL where the client can get access to this. So we generate those in a Lambda function. The user can, from Frontend, open up a WebSocket connection, and then we can push data to certain channels. So we just let the user listen to a stock updates channel, and whenever the step function, I'm pointing to my screen, but you can't see that. Yeah, Home Assistant for the win, definitely. I also use it. So the step function triggers every often that we want. It could be every second. It will call the Lambda, which is the function. It will take the current stock from Redis, and it will push it to all the users. I will answer the dynamic cron question later. There's also an admin feature where they can manage all the events and the products and all the business rules. They can also view orders, and they can also do some basic monitoring on the platform. And for that, again, it's just a Lambda function running. It's pulling its data from Redis, from Elasticache Redis, from DynamoDB, and an S3 bucket. So there we can make sure all the configurations are updated in Elasticache. And whenever we need order data, we can fetch it from S3. What was really showing the flexibility is because the client wanted to add a few features. And I think this is where an event-driven architecture really shows its power. Because what they wanted to do is they wanted to have an error when something went wrong. And also we are using this for the monitoring. So whenever a file is being put on an S3 bucket, it will execute the step function for the order handler, as I've shown. So that will take care of sending it to the vendors. But also the step function, it emits status events through CloudWatch. And you can listen for those. So whenever something messes up, the step function will have an error. And we can listen for that error event. It will trigger the Lambda, and we store records in DynamoDB, which is an optimized document store on AWS. And we also use this for successful triggers. So whenever an order was sent successfully, we just update it in DynamoDB. And we know how many successful orders were coming in. If there's an error, we update DynamoDB, but we also send an email so someone can have a look, like, okay, what went wrong here? What do we need to fix? Also, what was an added bonus here is that the client, of course, needed to figure something out for the current COVID situation, and they wanted to offer digital products, like having access to a live stream, a paid live stream. And that's something we didn't have before. But because we are storing all the ordered data in DynamoDB, the only thing we had to do is create an endpoint where a user can authenticate themselves with a token. They're using Gigya for that. Not sure if anyone knows it, but we can identify a user in this endpoint and find their order. And there I can just check if the user actually bought that product. And that's what kind of check they're doing in the front end. So this is something that was added later, which was for us, it only took 1 day to add this feature because the entire infrastructure was already there and we only needed to read it. And it was something that we could add as an extra feature without updating the entire infrastructure. So that is a really nice bonus. Of course, we had some learnings and we have some ideas for the future. I think the main learnings were that validation can be really hard. I think you all know that already. But if you're dealing with different kind of vendors, it's even worse because some of them require a state, which we call a province. Some of them don't. Some of them might change their requirements on the fly. So there was someone in Qdance that decided that they wanted to have the state as a required field, while we were not asking this to the user. So suddenly we saw all the orders coming in, they were failing on the merchandise. So we were figuring out in the logs, like, okay, we get a validation error. And someone got on the phone like, okay, why is this suddenly a required field? And they said like, oh yeah, that seemed useful for us. And it broke our entire shop. So that was really annoying. Also, we had that a vendor itself had an API update and didn't notify us. So it was also breaking. It also happened that the business changed its stock. So as I told in the beginning, if we get stock assigned to us, we assume it's all still assigned to us. We are the only shop that can take out of that stock, because otherwise it can happen that a user buys a t-shirt and it's being sent to the merchandise vendor and they say it's sold out, but the user does not get feedback on this because they already paid for it. So that's difficult. We had once that the dynamic cron stopped, so the cart removal process didn't work. And there were users that were seeing that tickets were sold out because they weren't given back into the stock. So that was something we had to fix. Qdance is part of IDNT Group, which has many different of these brands below it. And it seems that all of these brands have different needs. They all want to have different email templates. They want to have different front ends. They want to have different vendors. So that can also be a challenge. And serverless can sometimes be a bit of a black box. Like things happen, things might break, and you need to figure out how by just going through the logs in Amazon. And most of the time you can figure it out, but sometimes it can be quite difficult to figure out why. The future, we want to push more on order details, like in the admin, look up someone's order and actually get the entire order in there. It's perfectly doable because we have all those details on the S3 bucket, but it's simply not there yet. Also, there's a wishlist feature that we want to implement where users can go into the shop ahead of time without the option to buy, but at least they can select all the products that they want to have. And when the shop actually opens, they only have to go to the payment. What's also really interesting is the client wants to look into machine learning personalization, because we know the user because they're authenticated, and we know what kind of products they bought, and we might know what kind of artist is connected to the t-shirt that they bought. We could use machine learning personalization to maybe show them interesting products. There's more brands that we want to add under the from the IDT group, and also there's some interest from competing or like friend companies that they find this very interesting and they might want to use the same shop. And we want to connect more vendors so that the brands have more possibilities for selecting which vendors they want to use. I think the key takeaways are that please give serverless a try. It's really cool. I think for this project, I think a headless CMS is really amazing because the client didn't want to have running servers. And I think for this use case, I think Contentful is a great solution. But as I said, yeah, you can also run Drupal on Lambda, so that could have also been a good choice. Event-driven architecture is extremely powerful. You can just add stuff where you think, like I've showed the example, like, oh, now we want to have an endpoint where we can verify someone's order. It was just done in one day next to the existing platform because it just can tie into events that are already there. Also, don't be afraid to use different databases. We're using Redis for the really high performance stuff. We're using DynamoDB for the event data and the order data. And don't be afraid to use different kinds of databases. Not everything fits in MySQL, not everything fits in Redis, and not everything fits in DynamoDB. So don't be afraid for that. And by that, I think this is, in a nutshell, the one-stop shop project for Qdance. Thanks for your attention. I see the amount of visitors didn't drop, so that's pretty cool. And I see some questions there. So let's go over there. If there's more questions, please feel free to ask.
Yes, so thank you so much, Robert. And yes, if you have questions for Robert, please put a Q: in front of your question, and we'll get through them. We have plenty of time for questions with this session. So let's go ahead and start with Alexander Varvaek's section, his question, which is, the async functions to real-time process, dynamic cron, is a pretty clever solution. However, does being serverless at this point still weigh up to the added complexity of what would be relatively simple with a constantly running process?
Yeah, very good question, Alexander. You can also indeed decide to do this on a continuously running server. That server does require management. It needs to be keep it up to date, which is something the client didn't want us to do. So there was no choice. But once I finished the dynamic cron, I know it looks really complex seeing it the first time, but it's actually quite simple because it's all code as infrastructure. So there's nothing you need to point and click in the dashboard of AWS. It's all code. So you do serverless deploy and it's there. So for us, I think it worked really well. And also a regular cron does also not allow you to do something per second. So you would need to have some kind of continuously running process for it, which is possible. But I think if you go in that direction, you also need to do a lot of configuration and you need to find a mechanism on how to change it on the fly. So that's why I still think the dynamic cron is a better solution in the end.
Well, thank you, Robert. We have a question also, two questions from Alejandro, actually. First is, was this just a side project or are you building a platform like Eventbrite?
Let's see, where can I find this question? There. This is one project for one client. And it's not a platform for us. Also, Media.Monks doesn't really do SaaS, for instance. The client came to us like, this is a solution or a problem we have or we want to solve. Can you figure it out for us? We did. And as I mentioned, there's under the IDT group, there's many brands, including Sensation and Thunderdome, which might be known. They also intend to use it, hopefully after they can give events again. But also there's other large, dense organizers that have shown interest in this, which are not part of the IDT group. So it's their product. We build it. It's their product, and Qdance can do with it whatever they want. So it's not something reusable that which we are selling to other clients directly.
Thank you. Next question was also from Alejandro, which is, I'm just curious about why Vue.js was selected to do the job and why a third party built it. Can you talk a little bit about it?
Yes. Well, Qdance already had a vendor which is doing their .com, all their front-end work with Contentful. So he didn't want to bypass them by let us do the front-end, which is for us is perfectly fine. And what I understood, I'm not involved in how they do their front end, but what I understood is that they already built the Qdance.com site with Vue, and they already had a lot of components which they could reuse for the shop. And that's why they just reused Vue.js for the shop as well. But that's all I know about it, because I wasn't involved in the actual front end development itself.
Thank you so much. Next question is from Kevin. Would you need to use a custom Lambda layer for Drupal to be able to work on Lambda?
Yes, correct. Yes, you do need a custom Lambda layer. If you want to do PHP on Lambda, I would recommend you to use Bref. I think it's bref.sh. Let me look that up for you. Oh, this is actually handy doing a virtual event. So you can go to bref.sh, and it's basically a sort of plugin for serverless framework, and it will take the right Lambda layer and it will set it all up for you. That's really cool. I've done a Drupal prototype on AWS with CloudFront and Lambda and Aurora Serverless, and I was able to run Drupal fully serverless. So if it wasn't being used, it wouldn't cost you anything except for the data that you might store in those services. But it is possible. It's really awesome. I recommend you to try. But there's probably some things you need to adjust in Drupal to make it work. I remember hard coding some URLs because it otherwise wouldn't figure it out by itself.
Excellent. I think we have time for one final question. Obviously, if you have further questions, please feel free to contact Robert afterwards. This last question is from Alex. Is there a traffic level or number of requests where you see benefits or drawbacks of building serverless apps? I know one argument is no cost when serverless isn't running, but to a low traffic app, paying $10 a month versus 50 cents a month isn't a big deal for most businesses versus managing all the services for a small team of few developers. So do you want to speak to that?
Yeah, no, fair point. I think what I always tell people if they should or shouldn't go serverless, it's do you have a steady amount of visitors? If you do, then it makes a lot of sense just to have an EC2 instance or a droplet somewhere or a VM or a VPS, something. Makes perfect sense to have that. You know the cost. It can't cost you more than that. So if you're paying $10 a month for a server, you know it cannot suddenly go into 500. So definitely, if it works for you, I think it's probably best to keep it like that. For a project like this, they have these peak sales. So suddenly there's a huge increase of visitors. And the rest of the time, there's just a few orders per day, maybe. And then the platform itself doesn't cost anything, or it's cents a month. But also for these bursts of traffic, I think there's like maybe a bill of $100 a month, something like that. So then it's a really, really good balance. If we need to keep all of this infrastructure in the air to work with the amount of visitors in peak sale mode, then it would cost us, or it would cost Qdance a lot more money than it does now. So the lame answer is it depends.
As is
I
many
hope,
answers.
I hope it helps, Alex.
As are many answers to many questions. It depends. I'll open it up for one last opportunity for folks in the chat to share a question. Remember, if you prefix your question with Q:, we'll be able to see that and make sure to ask it. If not, I want to go ahead and thank my dear friend, Robert Sloches. Thank you so much for this incredibly enlightening presentation. I learned a lot. Oh, we have one question coming in. Alejandro asks, how much did this project cost? What was the budget?
I can't tell that. I'm not sure if, since this is recorded, I'm not sure if I'm allowed to talk about money.
Privileged client information. Perhaps the answer would be get in touch with Media Monks, and you can have a similar project.
Yeah, definitely. If you are interested, hit me up, then we can talk. Not enough. No, it's never enough. But now we are very good friends with Qdance, and also we've helped them a lot because they have a very hard time with COVID, because what they do is create events for up to 80,000 visitors, and basically they are told that they cannot do events until there's a vaccine, which means that if the vaccine doesn't come quickly, it might mean that they're out of business. So for them, this is really serious stuff. And when we were going to do the digital events, we were helping them doing fixing them with those endpoints to do their business, so they can at least get some kind of income through alternative ways.